Hi everyone, my name is Big Patana Montong Tununam. I'm a lecturer at the University of Melbourne, and today I'm very happy to present our paper titled Review Dynamics and Their Impact on Software Quality. In this work, we want to better understand the code review process. In particular, we want to know what information can influence the review decision of a reviewer. As you may know, code review is a manual practice to examine and improve the overall quality of a new code change. And in the modern software organization, a code review tool is often used to facilitate the code review process. So more specifically, everyone in the team, including author and reviewers, will work together through the code review tool. The code review tools often provide a transparent environment where everyone in the team can see other activities. This transparency can enhance the active collaborations and as well as increase the team awareness. Prior studies also show that developers can learn from others' code and review comments via this transparent environment, and expertise also can be perceived from this visible history of code change and reviews. However, since code review is performed by humans, it is possible that they might have some subconscious bias due to the visible information other than the patch or the technical content itself in the code review tool. These can occur in different forms. One possible is that when the reviewer and the patch author has a strong relationship. For example, Clark is a reviewer of my patch, and when he joined the code review, he can see my names as the author of this patch. Since we have been working together for a while, Clark might gradually build trust in my code, and then when he performed the review, he might did not provide a careful review and gave positive feedback to my code. This can be considered as in-group out-group bias, where individuals create a strong motivation to cooperate with in-group members. Prior study also showed that patches from a trustworthy author tend to take less reviewing effort. On the other hand, viewers with a weak relationship to the team, like the newcomers, face negative impressions during the code review process. Another possible scenario is when the patch author or reviewers have a higher social status. For example, I'm a reviewer and I can see that Ahmed's name as the patch author in the code review tool. Since Ahmed is a core or well-known developer, I might presume that he should write good code, so I did not give a careful attention and provide a positive feedback. This can be considered as a cognitive bias in terms of social hierarchy, where an implicit or explicit rank order of individuals or groups influence the other's behavior. Prior work also shed light that developers' reputation can influence the review decision. Another study also found that feedback from outsiders tend to receive less attention than the core members. The visible information is not only about the individual information. The visible feedback may also have the impact as well. For example, given that Ahmed and I are the reviewers and we already provide the feedback, and then Clark just newly joined the review and he can observe everyone's feedback in the discussion thread. Then he see that Ahmed and I already provide positive votes. He might presume that this patch is already good, so he didn't give a good careful attention to the patch. This can be considered as social influence, where popular opinions tend to continue receiving attention. From our manual observations in the actual data, we also find that some reviewers may make review decisions based on prior opinions. And for example, one gives a positive vote since the prior reviewer already provided a positive vote. On the other hand, another reviewer provided a negative vote since others have raised concerns. Based on these examples and motivation, we are wondering whether is there an association between the visible information and the review decisions or not. To investigate this, we used 8 metrics to capture the information that is visible before a reviewer will provide a positive vote. The metrics are grouped into 3 dimensions. The first one is relationship dimension, which captures the historical cooperation in the past between the reviewer and the patch author. The second dimension is the status, which captures reviewing activities of core member before the reviewer provides the feedback. And the last dimension is the prior feedback dimension, which captures the feedback of reviewers before the review provides the vote. And from these 8 metrics, we then use a mixed effects logistic regression model to model the relationship of this metric with the likelihood of giving a positive vote of a reviewer. A mixed effect logistic regression model is a statistical analysis that accounts for variance in multi-level data, which is the real decisions and the past data. So if we look at the formula, the dependent variable is whether or not a reviewer provides a positive vote, and the random effect is the reviewer ID. For the fixed effects or the X variables here are our 8 study metrics. Moreover, since several studies have shown that the past characteristics are associated with the review decision, we therefore use the past characteristics as a confounding and put them into the model as well. In this work, we use code review data from OpenStack and Qt projects as our case study, and after we build the mixed effect model for each project, we analyze the explanatory power of the metrics in the models. In other words, we examine which group of the metrics share a stronger relationship with the likelihood of providing positive vote of a reviewer. Interestingly, based on the log likelihood ratio test, we found that the metrics that capture visible information share much stronger relationship with the likelihood of providing a positive vote than the past characteristic in both projects. So when we look at the association direction, we found that the higher the co-working frequency in the past, the more likely the reviewer will provide a positive vote. And the higher proportion of prior positive votes, the more likely the reviewer also provide a positive vote. And lastly, the lower the proportion of prior comments, the more likely the reviewer will provide a positive vote. These results show that we can capture the characterize and characterize review dynamics, which is the practice of making a review decision of a reviewer. Moreover, despite the conventional wisdom that a pass should be evaluated based on the technical merit of a pass, our results show that visible information such as the relationship and prior feedback has a stronger association with the review decision of a reviewer than past characteristics. So this seems to be a little bit concerning, since not only past is taken into consideration, but other visible information like author names or prior feedback are also considered during the code review. Therefore, we further ask a question that if such a practice of making review happen often, will it pose a risk of having defect in the past or not? Hence, to answer this, we investigate the association between review dynamics and the likelihood that a patch will induce fix in the future. To do so, we first compute the review dynamic matrix based on our findings in the previous analysis. So for example, we find that the higher the co-working frequency, the more likely to provide a positive vote. Hence, we will measure a proportion of reviewers in the past who provide a positive vote when having a strong relationship with the past author. And similarly, we measure a proportion of reviewers in the past who provide a positive vote, then there are at least one prior positive vote. And we also measure a proportion of viewers in the past who provided a positive vote when there are no prior comments. And finally, we use the simple logistic regression model to capture the relationship between this review dynamic matrix and the defect proneness of a pass. We also use the pass characteristic and overall reviewing activities like the total number of comments and reviewing time as the confounding factors in the model as well, since prior studies show that these characteristics share a relationship with the defect proneness. And once we build the model and analyze the explanatory power of our review matrix, we find that the review dynamic matrix are significantly associated with the defect proneness. However, the association is not strong as much as the confounding factors like the past characteristic and review activities. So these results suggest that the practice of making a review decisions based on the visible information have a relatively small impact on software quality. So we can conclude that visible information may have implicit influence on the review decision of a reviewer. However, such review dynamics should not be too concerning in terms of the software quality. And that's all for my presentation. Thank you for watching.
Hi, I think we are live. So welcome everybody again to the Code Review Observational Studies session. So today we have with us Patanamon Thongtanunam. I'm not sure if I said the surname
That's
properly.
correct, yes. Yeah.
Thank you. And she's going to answer all the questions you may have about her wonderful work. Okay. Well, it seems that we have some questions, a lot of compliments. So Mauricio is asking, well, he says that interesting findings. He's congratulating you for your work. And his question is, would a control experiment where one group sees previous comments and another does not a good extension? Do you see value in such an experiment?
Absolutely, I agree. The control experiment will give us more insights and more explanations what actually happened with the developers, and is there the actual subconscious bias in that or not? Because of the data that we analyze, it's just showing the correlations, but we cannot draw any conclusions about the causations. Yeah, so that's a very good point. Yeah, thank you.
Okay, thank you. So Max Gesellbacher is also congratulating you for your great work. He says, very interesting results. Thanks for the presentation. And now he's asking, can you suggest technical and or social means to lower the effects of those review dynamics?
Yeah. So one I think is could be very similar to the academic peer review process, where if you really want to avoid this kind of bias, we can do like we hide the feedback before the reviewer provide the first feedback, so then they can focus on the patch itself rather than reading other people comments. Another thing that we can do is we can maybe just blind the author name, so then we can reduce some subconscious bias. But there is the good thing is that we can reduce some bias, but the downside is that they might reduce some collaborative nature, because we don't know who they are, and then they might not willing to contribute more. I'm not sure, but like there is pros and cons, and we need to further investigate whether should we do that or should we minimize that those kind of subconscious bias or not. Yeah.
Okay, thank you. So more congratulations from Lloyd Montgomery and from Alexander
Thank you
Cerebrani.
so much. Yeah.
And so far there are no more. Yes, one question just up. So Felipe Ebert is asking, do you have any insights on what developers would think about such double-blind code review?
Yeah, so that's a good question as well. Uh, it would be interesting to do some interview or survey with the developers. And actually, if you look into the internet, there is an article talking that the Mozilla projects, they start to do an experiment about double-blind code review, because they kind of believe that there is a bias in gender. But I still don't see their results and finding yet. So there might release something already. Yeah, so it might be worth to check. Yeah.
Okay, so another question from Matteo Patengi. Thanks for the talk. Which patch metrics did you use more in particular?
Yeah, so I use the common metrics that measure like the added line, the size of the patch, which is the add and deleted line, the experience of the authors. I'm not sure, but there are a couple more, but I don't remember now. But mostly those metrics are the well-known metrics that usually share a relationship with the defects. Yeah.
Okay, thank you very much. So Alexander Serebrenik is asking, your study has shown that the biases do not impact software quality. However, code reviews are also used for other purposes, such as learning, knowledge sharing. Would you expect the biases to influence the learning side of the code reviews? For example, I am not learning that much because I trust the author,
Yeah, I think it could be possible. It could be possible about that. It could be another way, right? The reviewer doesn't want to learn from the newcomer because they think they're too young or they're novices. There could be some ethics, yeah. But it's very interesting to see that, yeah.
Okay, so it seems no more questions in the chat for the moment. I don't know if some other questions will pop up. But since we still have like 4 minutes and a half, so I'm going to ask you some questions.
Yes.
Well, first, I think I would like to congratulate also, because I really liked your work very much and I enjoyed your presentation a lot when I saw it before the session. I have a couple of questions. So the first one, I'm not sure if it really makes sense or not, but maybe you can help me with that. So typically, when we talk about code review in general, we don't specify, or many times we don't specify which is the code review technique that people are using. And that could translate into different people using different type of techniques for reading the code. I'm not sure if in your paper there's that kind of diversity in terms of what do people understand by code review, or what if you know what code review technique they were using, or I'm just trying to understand how homogeneous or heterogeneous the sample was in that sense.
So I think I'm not sure as well about the reviewing techniques, but in general, the process should be very similar to many open source projects where it's open to anyone to come and read the new patch and then provide feedback or improve the patch directly by themselves. But I think there might be some diversity, like for example, in terms of the process. For example, the projects that we study, they heavily use the votes as the indicator of whether they want to accept or not. But in some projects, they might not use the vote as an indicator. So in that case, it will be hard for my study to understand this kind of the review dynamics. So, and then there are lots of variation in terms of the process as well. Yeah.
Okay, so in the meanwhile, a couple of questions have just come to the chat. So Isaac Tosun is asking, shall we see code review as an activity that helps to keep the quality of the source code rather than an activity that improves the quality? Does your study imply that code review does not improve the grade quality? And then I don't know if it's a continuation of the previous, or is it the dynamics effect on the effectiveness of code review?
So actually, there is many studies already investigate whether code reviews can improve the quality of the software. And so basically, more code reviews, the better, the less defect, the better the software it is. But the finding that I show in this paper, we just mainly focus on the review dynamics, which is like a particular characteristic made features in there. But for the other characteristic, like the overall review activity or the number of people, we also consider in our data analysis, and those activities have a strong relationship with the defects, which means if there are more people, the quality of the software is better. So the short answer is code review improve the quality, but only the review dynamics doesn't have an impact on the software quality.
Okay, yes. Thank you very much for all your answers to the questions. So now we have only 20 seconds to go. So I'm afraid we don't have time for even a very quick question. So you will be automatically, well, I don't know. No, you will be moved if you wish to continue the discussion with Patanamon to a discussion room. Okay. So, and to the others, I will see you in the next paper. Thank you.
Thank you.